basically, the basis of my presentation comes from 3GPP IPv6 study where 3GPP is sort of looking into what has changed since we implemented IPv6. So basically, what are the differences in so far? What is changing in the world? So basically, they have identified that we have most of the technology already in the 3GPP specs. We have the nodes deployed, so we have all the big vendors are deploying nodes that are IPv6 capable and have been actually IPv6 capable from since 2004 or so, at least. So there are the sort of main components are in place. You can do IPv6 in mobile networks if you want. The question has more or less been about the incentives to get IPv6 traffic into your network and about how do you actually get IPv6 services rather than how do you do IPv6. So let's look at some more detail. What do we have in the networks currently? So typically we have both capabilities, IPv4 and IPv6. We can run them in one tunnel, user tunnel, or two tunnels. We can do IPv6 separately on transport level or separately on user plane. There is really many different options. We have terminals that support IPv6. I have one in my pocket, which is already quite many years old. That's supporting most of your phones probably support IPv6, but usually it's not turned on. That's still sort of the problem. That the operators have not just turned on that feature. And there has been many trials, many trials around the world and in Finland. For example, Ericsson was one of the very first to get IPv6 running in their networks and doing trials on IPv6. And you can actually, as Joni already mentioned, you can get IPv6 connectivity to your cellular if you want. So that's not really the problem. The problem has really been the services. How do we get them? So traditionally, what 3GPP does is they look at this picture. Okay, we have the terminal, we have the base station, we have the GTSN or PDN gateway. That's it. There is the border. That's where our sort of business ends. But in real life, the scenario they have admitted it's like this: that we have the terminal, we can have behind the terminal a laptop. We have still the base station and the PDN gateway. Then we have the actual internet backbone where we get the services, and there we can have Facebook, Google, all the other players that are on the market. So deploying IPv6 in 3GPP network, it's not about sort of getting your access network to support IPv6. It's more or less getting all these things right. So getting your operations right, getting your roaming agreements right with the other mobile operators, getting the charging systems to run on IPv6, getting services on IPv6, getting legal interception for the governments running on IPv6 that they can monitor your calls or whatever. So there are a lot of other things that are not sort of technically related, but you still need to get them fixed before you can actually run IPv6 everywhere. So there are some scenarios identified on how do you actually get some IPv6 traffic into your network. So one of the big class of services that you can do is to actually get your own services running on IPv6. So basically, your IMS services is one of the potential IPv6 sort of enablers in your network. Then, of course, getting your internal transport network running on IPv6, because mobile networks use tunneling for the user traffic, so you can get the transport network running on IPv6 without sort of user noticing it. And then there is, of course, the sort of generic access to internet on IPv6. And as a last, but that's the sort of most emerging scenario is the DSL replacement. So in rural areas, there is a lot of need for something else than copper for the last mile technology. So basically, when we install these semi not really mobile stations, but they are sort of semi-static stations that are just using the mobile networks as an access technology. So that's an obvious scenario that we can see IPv6 coming on. So okay, so what do we have then on the user plane? So basically, on the user plane, 3GPP networks typically support three different types of bearers. So basically, when you set up a connection, IP connection from your mobile phone, you select one of these or few of these bearer types, which sort of defines which type of addresses you will get to your terminal. So you can choose between setting up a IPv4 only bearer, IPv6 only, or dual stack. So basically, as the name implies, you can sort of imagine what you get. But you can still do also that you set up IPv4 and IPv6 only bearer types at the same time. That means just that you have two tunnels from your terminal instead of one. So it's possible also. And the original standards actually said that you should do with two different types of bearers. So basically, one for IPv4 traffic and one for IPv6 traffic. And the dual stack was sort of added later. Yeah. So let's move on to these. So operators' own services running on IPv6. This is an easy sort of. You can see that it's easy because you are the only player on who you have to talk with. So you don't have to talk any external parties that, hey, I need your services on IPv6 because I have these clients that are using IPv6 on their terminals. So if you want to run IMS on IPv6, go ahead, configure your IMS on IPv6. It will support both versions. If you want to run your IPTV on IPv6, that's also sort of easy task. It's more an operational task rather than a task of negotiating with anybody. So what we are seeing that are the drivers why should operators do this are sort of the IMS will be the the thing that you use for traditional VoIP calls in LTE network. So basically, every terminal will have an IP address all the time allocated, meaning that everybody who is connecting to the IMS services will need some kind of IP address, and probably you don't want to use private addresses for that that go through some NATs before you hit the IMS gateway or something like that, because that would basically mean that you have to keep up the NAT data on those. So basically, as a solution, you have two possibilities. Do the complex NAT traversal stuff, keep alive through NATs, or then deploy IPv6 for the IMS services. So there you have a sort of very good driver and easy to deploy. Then the sort of user regular traffic to internet. So for example, Facebook, Google, Microsoft, those. Here we are sort of, or the whole 3GPP and mobile operator industries is really dependent on what's happening on the other side. So what's happening on Facebook and Microsoft and Google. Well, Google is a good example. They are deploying IPv6 very heavily, and you can make deals with Google to get actually IPv6 traffic in. But they are also the ones that are sort of making a lot of NAT findings for operators in their NATs. So basically there is sort of impact also if people start to use and have the always on terminals, and they will be all the time sending updates to Facebooks and stuff like that. So it will be something to consider for the operators, how they actually get this traffic into IPv6. So basically, there as solutions, we have these Google type of solutions. Google is offering IPv6 for all operators that are willing to sign a deal that, okay, I have a quality IPv6 service in my network. I do debugging on IPv6 if there is any problems. I have these SLAs in place. So then you can get actually Google to resolve as a quad A record instead of a record as it usually does. So that alone sort of gets you a lot of IPv6 traffic into your network if you do this kind of deals with Google or any other parties that are actually creating a lot of traffic in your network. Then DSL replacement as a sort of scenario, what are the why people are using or wanting to use it is basically the reason is that, as said, in rural areas you don't necessarily want to build up the cables all the way to the last mile. So you use actually the cellular network as a replacement for the last mile technology. And there usually you have a multiple computers behind the terminal then, and then you can see that they are creating more and more these NAT states in your network, and probably also wanting to consume more IPv4 addresses. So this is an obvious place where, for example, if it's a corporate sort of some small office somewhere, they could offer that, okay, please use IPv6, you get better VPNs to your corporate environment if you are using IPv6, because you don't have to do all these NAT pass-throughs on your VPNs and stuff like that. But on the other hand, on IPv6 side, there is these efforts already going on, by the way, on prefix delegation, that we need then prefix delegation again in the 3GPP network. So that is currently not supported, but it's an effort that is sort of going on the